Hello, and welcome to the Flip Robot e-learning module. In this module, we'll be looking at Topic 3 of STEAM Ability 1 for Flip Robot, the Light Sensing Insect Simulation Limbed Robot. In this course, we'll cover the following topics: the learning outcomes derived from Topic 3, the function of the additional hardware included in the Topic 3 extension kit, coding Topic 3 through the Variable Control Board, and coding Topic 3 through Flip Code. When you finish this topic, you will have learned the real-world applications of robotics involved in Topic 3, how to utilize the additional hardware involved in Topic 3, how to program Topic 3 through the Variable Control Board, how to use and not statements in coding, how to program Topic 3 through Flip Code. Through the curriculum of Topic 3, students will be introduced to two real-world applications of robotics. These are the four-link mechanism and the light attraction principle. We will now discuss each. As Topic 3 moves from wheel-based movement to limb movement, students will learn about the basic principle of the four-link mechanism. The four-link mechanism is made up of the crank, connecting rod, rocker, and line of centers. This type of technology is used in real-world applications such as the construction of bicycles and how windscreen wipers work. Using the core principles of the four-link mechanism allows students to experiment with different limb constructions and provide alternate movement methods. The light attraction principle is an instinct commonly found in insects whereby they use light as a means of navigation. Naturally, insects will use the angle of a light source to determine whether they are moving in a straight line. Therefore, insects can be naturally drawn to light sources as the angle constantly changes, however the creature believes it is still going in a straight line. Using the light sensors included with Topic 3, students will recreate this natural phenomenon and gain an understanding of how creatures can be attracted to light. We will now go over the primary hardware components that are included in the Topic 3 extension kit. These are the beams used for leg construction and the light sensors. The Topic 3 extension kit comes with 8 construction beams used for building the limbs of the light-following robot. For the recommended construction of the limbs, all 8 of these beams are required. However, there are other limb combinations which require fewer or require different holes to be used. We will look at creating the recommended limb construction shortly, but after this course, feel free to experiment with different combinations of beam configurations to see if movement can be improved on the initial design. The Topic 3 extension kit comes with 2 light sensors to be installed at the front of your Flip robot. These sensors detect white light and they will send a signal to the Flip brain to respond accordingly. This is very similar to the infrared principle we discussed in a previous e-learning module, with the main difference being the sensor responds to the radiance of light rather than the changing of reflected light. The light sensors work best when in a dark environment, so there is no interference from residual light sources. So ensure when running experiments with the light sensor that you have the room as dark as possible. We will now look at programming the light sensing limb robot through the variable control board using the default firmware for Topic 3. Before we begin, however, we will need to construct the light sensing limb robot to begin coding. Take the time now to build the robot as shown here. You can refer to your user manual on the steps for construction, and once done, please continue the module. As we covered in a previous e-learning session, the default firmware is used to code Flip Robot via the variable control board. Each extension kit has its own set of default firmware, as the programs change depending on what is connected to it. Therefore, before we begin, we will need to download the default firmware for Topic 3. To do this, go to Flip Cloud and enter the Case Curriculum section. From here, select Topic 3 from the menu options. Once in Topic 3, scroll down to the default firmware option. With the Flip Robot connected to your laptop and turned on, select the Flip Brain and port and then press Upload. Once done, the lights on your Flip Robot will flash and you'll hear a musical chime to know the upload was a success. Go ahead now and upload the default firmware to your Flip Robot for Topic 3, and once done, you can continue the module. Similarly to the default firmware for Topic 1, the first mode of the default firmware for Topic 3 uses the remote control to move the Flip Robot. Using the remote control in this mode will give you a good indication of the movement and steadiness of your limb design. Simply plug the remote control into one of the ports on Flip Robot, which you may need to disconnect a light sensor to do, and then the robot will react to the remote control to move each set of limbs forward and backward. Buttons 1 and 2 will move the left limbs forward and backward. Buttons 5 and 6 move the right limbs forward and backward. Practice having your limbed robot move forward, backward, and make right and left turns. Once you have finished practicing this movement, please continue the e-learning module. We will now put your remote control skills to the test. Set up a course similar to the one that is shown here and have your limbed robot weave through the course using the remote control. While conducting this experiment, think back to when we performed the same challenge using the starter kit and how different the experience feels moving from wheeled to limbed movement. Once done, please feel free to continue the module. To access Mode 2 in the default firmware, press the default firmware mode button at the top of the FlipBrain once to get to Mode 2. The second default firmware mode looks at using the light sensors to move FlipRobot. The way the variable control board works is very similar to the infrared sensor for Topic 2, in that each of the first 4 dials is programming the FlipRobot to react in a different way depending upon if each light sensor is detecting light. We will now run through each dial individually and explain what they do. Dial 1 determines what the FlipRobot will do when neither light sensor detects any light. Dial 2 determines what the FlipRobot will do when only the right light sensor detects light. Dial 3 determines what the FlipRobot will do when only the left light sensor detects light. Dial 4 determines what the FlipRobot will do when both light sensors detect light. You can refer to the image shown to see the dial positions for the various actions for FlipRobot for each of these dials. Dials 5 and 6 control the motor speeds for the left and right DC motor respectively. Dials 7 and 8 control the sensitivity to light for both the left and right light sensor. Our recommendation is to set these to the maximum setting for the best effect. We will now put your variable control board skills to the test. Design a maze like the one shown and guide your FlipRobot through the maze using only a torch and the settings on the variable control board. Once you are done, we will begin coding the light sensors using FlipCode. We will now look at how to code Topic 3 Extension Kit in FlipCode and the key programming logic taught through this coding. Through the coding activities involved in Topic 3, students will learn 2 new programming logic functions. These are the AND function and the NOT function. We will look at each of these functions individually and learn the premise behind them and how to build code using each of these functions. In Topics 1 and 2 of the FlipRobot curriculum, we worked with coding an individual sensor, being either the ultrasonic sensor or infrared sensor. With the addition of the 2 independent light sensors for Topic 3, we need a way to program each light sensor around an if-do statement. This is where we add an AND command. By utilizing the AND command, you can link 2 different inputs together in the same if-do statement. We will now look at creating a program in FlipCode that utilizes the AND command. To begin the program using the AND statement, we will first need to create the functions for forward and stop. You can refer to the Introduction to FlipCode e-learning module on how to create functions, should you need more information on how to create these functions. You will also need an if-do-else block, so go ahead and grab this from the logic menu and remembering to use the cogwheel to change the if-do block to an if-do-else block as shown. Once this is done, we'll be looking to add our AND statement into the code. The AND statement can be found in the logic section of FlipCode, so go ahead and grab this block and connect it to the if portion of our if logic block. Now that we have the base of our code, we'll be adding the light sensors and the commands to be conducted from those light sensors. To begin, you'll need to grab the comparison block from the logic section and the number block from the math section, so grab both and connect them as shown. We will now need to grab our light sensor function block. You can find this in the sensor menu, so add this to the block as shown. We will now want to set the numeric value to 30 and change the equal symbol to a less than symbol. This block now indicates that if the light sensor in port 1 detects light less than 30 centimeters away, the FlipBrain will react. Now copy and paste this part of the code as shown, and on the newly created block, change the port number to port 2, so both light sensors will now react. You can now plug both blocks into the AND statement as shown. We now have a code that reads if both light sensors detect light, then an action will be taken. Finally, we will add in our functions so that if light is detected, the robot will move forward, else it will stop. Go ahead now and upload this code to your robot to see the reaction of the light sensors to this code. Once done, please continue the e-learning module. The NOT statement is the second programming logic learned through topic 3. The NOT statement is used in conjunction with the AND statement to exclude the parameters of an input from the AND statement, basically allowing one input to react positively and one to react negatively to a command. We will now look to build on our previously created AND statement by adding a NOT statement to illustrate this point. Here we can see the program we created involving our AND statement. I have added a new function for write, as we will need this for the following program, so feel free to create this function. We will now copy and paste the entire if-do statement we created earlier and attach to the bottom of our current if-do statement as shown. Now we will add our NOT statement, so you can grab this from the logic menu and we're going to place it in the first light sensor block as shown. The instruction we are now giving to the flip brain is that when you sense light in the right light sensor but not the left light sensor, then cause an action. Finally, replace the forward function with the right function as shown. We now have a program where when your flip robot senses light in both light sensors, the flip robot will move forward, and when it senses light in only the right sensor, it will turn to the right. It is now time to put your coding skills to the test. Set up the same maze as you did for the variable control board, but this time look to navigate your flip robot through the maze using only code uploaded from Flipcode. When you have completed this challenge, you can continue the module. You have now reached the end of this e-learning module. Over the course of this topic, you should have learned the real-world applications of robotics involved in topic 3, how to utilize the additional hardware involved in topic 3, how to program topic 3 through the variable control board, how to use AND and NOT statements in coding, how to program topic 3 through Flipcode. There will now be a short quiz. Once passed, the module will be complete.